Please. Okay, so today I'm going to show you, start showing you how to get data from Google Earth, and then show you how to get data, different types of data from Open Topography. And then important for everyone, Rachel is going to show you how to make high quality maps using QGIS. In other words, to put a scale bar and north arrow and so forth, and make them look nice. So anyway, please don't hesitate to interrupt and ask questions. And Rachel, if you could monitor the chat and feel free to interrupt if there's questions, that would be great. So we're going to start with Google Earth. So for a few of the assignments, you're going to have to go into Google Earth and get pre-earthquake imagery. So in particular, you'll do this for the EMC, NAPA, both of those with the geologic map, and then for the NURA earthquake. And so you opened up Google Earth, looks approximately like this if you zoom into Tempe. And there's a few important things to know. First, that we don't want you to look in any detail before you set the imagery to be before the earthquake. And so to look at older imagery in Google Earth, you want to go to this clock button up here. And then that opens up this toolbar where you can see all of the images that were in that area. And so Tempe being an urban area, there's quite a few. If you go somewhere like NURA, there's definitely going to be fewer, but there's still some high quality imagery. And so you can move this toolbar, this bar back in time to then see older imagery in Tempe. If you look at this in Arizona, you probably see less and less development as we go back in time, for example. So this is looking at an image in 2009. Does this make sense? So again, if you're say looking at EMC and you want to get pre-2010 earthquake, you want to start quite zoomed out like this so you can't see any of the faults in any detail, and then make sure that the time here is before the earthquake. And then the next step is to save the imagery. And so imagery in Google Earth, when you save it, it's not georeferenced. And so you're going to be working with Rachel to georeference the imagery so that then you can plot it on QGIS in the right location. But we'll practice this for Tempe, and I'll show you how to save an image. So yeah, we'll show you first how to save, and then we'll show you how to get the correct image. So you can go to File, Save, and then Save Image. And I want you to then pay attention to this area that says resolution. So current resolution, the image will have about 1,000 by 700 pixels. But Google Earth gives us this option to save at these different scales. So we want to save the best resolution imagery that we have. Is there a question?
I just put that you make sure to like undo all like the borders and labels and stuff before you save the image, because it won't really be necessary when you import it into QGIS.
Excellent. So you see here that it says that the maximum resolution that Google Earth will let you save is about 5,000 by 3,000 pixels. And the best imagery happens to have about 1 meter per pixel. And so to maximize the quality of the imagery, you want the distance here, the east-west distance, to be about 5 kilometers or so that you'll have 1 meter per pixel, and you'll therefore then save the imagery at the highest quality possible. So to check that you have this 5 kilometers, you can take the ruler tool, make sure you put it in kilometers, and then you can stretch it across your image. So here, this is probably about 6 kilometers. So what I want to do is zoom in. You actually want to make sure that you're looking straight down and not to the side. So we'll change that. So yeah, now we're looking straight down. Can be helpful. Put north arrow up. Now that we're back in this perspective, we'll measure again. And so now we're at 5.5 kilometers. So you can zoom in just a little bit more, measure again. So now it's at about 4, so this is good enough. So we'll remove the ruler, and then we'll go back up to File, Save Image. And then remember, we want to set it at this maximum resolution, remove the labels and roads and so forth. And then you can go to Save Image. So you could put Tempe and then say the year to have some knowledge and remember what you saved, and then put a good place to save it. So Documents is fine for now. And then you can press save, and it'll take Google Earth a few minutes to save your image. Are there any questions on how to do this?
Just a couple quick additions. One was if you hit the keyboard R, that will get you vertical and north, and for sure, rather than doing it manually. Second one, and just to reiterate what Rachel said, is on the lower left, you can make sure you don't have the places turned on, just because all those little blue dots and the yellow ones are distractors.
So yeah, you can come down here, make sure they're turned off. Many of the places, it's rural enough that they're not really a problem, but you do want to turn them off. And then, yeah, you can click the R button to make sure that you're have north up and you're looking straight down. So just fix that. Are there any other comments or questions?
It might be jumping ahead a bit, but something that I find helpful, because you guys are gonna maybe have to do more than one of these. And so in Chelsea's video that she already posted, she said if you just keep the same zoom and scroll down, it'll keep you oriented. But something that I also liked to do to like keep track of where I was to add a path right here and to just mark out the extent of the square that I just saved. And then so when I'm ready to like make another one, I know exactly like how far to drag down and over and what zoom I was at previously.
Yes. Yeah, so say you're moving along strike. So say you have this image, then you can draw that area that Rachel had, or you could say, remember that there's this big freeway, and then you just move the freeway to the other side of your image. And then here you have a new area with a little bit of overlap from where you were before. And so we generally don't want you working together, but the exception is on getting these images. So you can work together to get them. And then if one person, say who's doing the neuromap, asks Rachel to georeference an image, then that image will be available to everyone, which largely decreases the work for Rachel on the georeferencing. Okay. So we'll now move then to open topography, show you how to get some digital elevation models. So here we are at open topography. Add the link in to the chat. You don't have to follow what we're doing. Just let me know if you have questions. So we're going to first just demonstrate how to get a shuttle radar topography mission data from Open Topography, which is used for a number of the projects. So this is a map showing where LiDAR data is in Open Topography, but there's global satellite data over most of the planet. And so for today, we're going to go to Napa here, just north of the Bay Area, and put a box over the area. And then you'll see this area that says global and regional digital elevation models. So you want to click that. And then the one that we're going to use here is the shuttle radar topography mission. And then you want to come here to SRTM GL1. And so this is going to be the 30-meter data. You can see here it was collected in early 2000. And so it predates all of the earthquakes, the exception of the Bora Peak. And so that's why we're going to be using it as kind of a low level or low resolution data set, but that's available everywhere, almost everywhere. So here we are looking at Napa. And come down and you can essentially, I believe, just agree or keep all of the default settings in Open Topography. And then if you're not logged in with an account, you'll just want to put your email here. And then you can press submit. And then, so this Open Topography is now generating the raster digital elevation model for the area that I selected. So let that finish. You can keep this page open, or when your processing is finished, you'll get an email which will take you back to this page where you can download the digital elevation model that you processed. So then the next thing that you'll want to do with the data is to produce a digital elevation model. So I'll show you how to do that in QGIS. So one of the challenges with the SRTM data is that the horizontal and vertical coordinates are different. Horizontal coordinates are in units of degrees, so latitude and longitude, while the vertical are in units of feet. And so we have to tell QGIS that the units are different. So here's a different similar map from SRTM digital elevation model, which is now loaded in QGIS. And so I'll show you how to make that digital, the hillshade. So make sure it's highlighted, go to raster analysis, like you guys have done many times. You can keep the option, many of the options the same, except you'll either want to change the.
Can you give us a minute to catch up, please?
Yes. While people are catching up, are there any questions? All right, can I keep on going? take a pause in a few minutes again. Comments, questions? Okay, so if you're here now doing a hillshade, what you want to pay attention to is either the Z factor, which is the vertical exaggeration, or the S or scale factor, which is the reciprocal, essentially, which is the ratio of vertical to horizontal units. And so there's a lot of tutorials and web pages online that will help you figure out what these terms should be. So for example, one of them is this page by Esri, which is for ARC products, but the same works for QGIS. It tells you how to set the Z factor. So I'll put that into chat.
Are these links available online?
So this I found just by searching Z factor hillshade or Z factor arc.
I also reference it in the tutorial video that kind of goes over the same thing, so you can see the link on the video too.
And so this will tell you how to set the Z factor. I typically prefer to set the S factor, but you can set wherever you want. So if you come down here, it'll tell you the latitude. So you want to know approximate latitude of where you are. You can always search. This is Napa, like Napa latitude, and that will get you close enough. I believe it's between 30 and 40 degrees. Then you want to make sure you know if your data is in meters or feet. So SRTM is in meters, and so we'd want to select either one of these two Z factors to produce the hillshade. So we'll take this one. And then here's my hillshade. So you can set the Z factor like that. And then I think that's correct. We'll run that. So then very quickly, QGIS made the hillshade. It's a pretty small area, so looks a little bit low resolution, but this is correct. Are there any questions? So let me show you what it looks like if you do it.
One small clarification, Chelsea, just, I thought you said earlier, the units were different, but it's not so much that they're different in meters and feet, it's they're in degrees and meters.
Yes.
So just to be clear, that's the difference.
Yeah, so you can come up to get the information. And you'll see here units, usually telling you about the horizontal units. And these should have a sense that these are what units are in longitude and latitude. Yeah, and it tells you degrees. And sometimes these data sets will tell you the vertical units as well. I don't see it here.
So the point is, in this case of degrees, like unprojected data, you have to do this vertical exaggeration correction. If the data are in UTM, meters and meters, you don't have to. It'll make the clean hillshade. So just people should be aware of that.
You also have to do this for bore peak, which is in the mapping repeatability. And so let me show you what happens if you don't do this change. And we just assume that the data have say horizontal and vertical units both in meters. So we're going to leave the Z factor at 1 and the scale factor also at 1 and run. So that then made this hillshade here. And so you do kind of get the sense that there's this topographic relief, but it just looks a little funky. And so if you process Bora Peak or SRTM topography and it looks like this, it's because you haven't entered the Z or S factor correctly. And yes, as Ben says, you can do a projection and you can put everything in similar units. Although I have opinions about, just be careful doing things in Web Mercator though, because it has a massive skewing of units, especially near the poles. And so angles can look, or areas can look quite different. So just, yeah, be cautious.
Question, do we need to change the Z factor or the S factor or both?
One or the other, not both. There's generally more stuff online telling you how to change the Z factor because ARC will, I believe, only let you change the Z factor. But QGIS specific web page information will also tell you, well, tell you how to change the S factor instead. But yes, it's just one of them. If you do both, you'll have basically the opposite problem. And again, for this project, like we've been doing through the semester, it is important to make hillshades looking at these two different angles and to make slope shades, which you also have to do this for. And so do remember to bring in what you've learned, everything that you've learned in the first part of the semester. All right. Are there any other questions on making hillshades? Okay, so I have one more thing to show you. And then we'll have Rachel's demo. So we're going to go back to Open Topography. And now I'm going to show you how to make a digital surface model and digital terrain model. So remember, a digital surface model is looking at the elevation of the top of the landscape. So this will include trees, houses, and so forth. And a digital terrain model has the trees and houses, all vegetation removed. So you're essentially looking at bare earth. And for these projects, especially Napa in particular, it's really important that you generate both of these products from Open Topography because the landscape looks very different. And it's important to see how the landscape looks from these two perspectives. So we'll go back to Napa. Now we're going to look at the high resolution topography. So in this case, it's LiDAR. You see here, there are these two data sets. There's the 2004 earthquake and then this Napa watershed data set. And always want to be careful to get that pre-earthquake data set so you don't see the faults that you're working on mapping. And so for this case, we're going to get the Napa watershed data. And then you want to come here to point cloud. So that then takes you to this page where you can start processing data on Open Topography. for especially the LiDAR topography, I do recommend that you make an account with Open Topography because you can process substantially larger data sets. And so it'll just take you much less time. So here I've selected this area. And then at this point, just choose return classification. There's ground unclassified. So this is the full data set. So this will generate a digital surface model. So it can come down and leave all the other windows unchanged, and then put, for example, digital surface model Napa. If you're mapping this area, you're probably going to make multiple of them. So to help keep things straight, you might want to add a -1, and then the next one you'll do will be a -2, and so forth. So then you can say submit. And now this Open Topography is going to produce a digital surface model for us in that area where I put the box at the beginning. Now a slick way to make another topographic data set in an adjacent area or the same area again is to say modify and resubmit this job. So we're going to click that. And then that brings me back to the page where I was before, and it has the same polygon open or selected that I had earlier. And so if we want to make a digital terrain model, in that case, we want only the ground points. So we're going to come down to coordinates and classification, and we're going to turn off unclassified points. So we had previously 108 million points or so, and unclassified, which is essentially, now we have only ground. Now we only have 35 million points. So we've really lost a lot of the points that represented vegetation or buildings. And it's because we modified the job, we know it's in the exact same area as the digital surface model that we were processing at the last step. We can come down here, and now this is a digital terrain model. So we'll just change the S to T and still in this one area. So then we'll press submit. So now it's processing. And then, so say we want to now move to the east, say, and process another data set. So this is the area that we've been processing, can then come and just—
Sorry, Chelsea, did you hit modify and resubmit again?
Yeah, so it's this button here. So you can click this as many times as you want, and it'll save the default options that you had from the previous job.
Can you say again how you made sure it was the older data?
Yes. So you can go to data. This shows you all the data Open Topography has. And then we're going to go to the Napa area. And then you see it has these two data sets. So if you click each one, then you'll see, come down to a full data set metadata, and you see survey date. So this tells you here it was a 2013 data set, and the earthquake, I believe, was August 2014. And so we know that this was before the data set.
Okay,
For the
thanks.
earthquake versus, I guess it was August. This one here is September 2014, so it was after. So you do have to know when the earthquake happened, and then you want to check the survey date. Are there any questions? Comments? Confusion? Okay. Rachel, would you like to show us how to do how to make a map, good map in QGIS?
Hang on,
Um,
you didn't do like the east thing. You didn't do that part. Like
Sorry.
how to move and make sure it's,
Okay, I'll show you.
sorry, I thought you were gonna continue doing that. That's why I didn't say anything.
No problem. Okay, so say we pick that area. We want this pre-earthquake data set. So it's this box that I've selected here. Just make it a little bigger. And then come down. So there's going to be a digital surface model, call it 2, just a different area than 1. Press submit. And then wait a split second. And then you want to come back up to modify and resubmit this job. And then, so if you want to just process along an area, then you want to zoom in, move to the next region. And then this part is a little manual, but I think it's can work quite well. Is you'll say select a region, then you want to remember where you put this box. Maybe put your hand on your screen to see where it was. And then you probably want a little bit of overlap. So move the cursor just to the west of the boundary. And then it's up to you to manually draw and remember where the southern extent of the box was. So now you're here and you can process this area. Bookkeeping, remember to move it to 3 and say submit. And then you'll just keep on doing that to cover the full area. Does that answer your question?
Yep, thanks.
Great.
And so the map example will be of the same area for the tutorial video I made, but this one will just be kind of a slower walkthrough, and I'll show some other little like tips and tricks on how to make a map in QGIS. So you'll have to do this if you ever want to make a figure in QGIS for your report, or when you want to export your map in like a professional standard that includes the scale bar, north arrow, legend, caption. So this is for Walls Creek. And so the first thing you want to do before you go to the layout manager is to click off all of the layers that you don't want visible on the figure. So I have all of my layers shown right here. But let's say I just want to have the GIR and the fault confidence ranking. So I can go over and click off all of these layers that I don't want shown. And you'll also have to choose what kind of base map you want everything to be splayed on in the picture. I find that with hill shades, the rest of the mapping symbology looks very clear, so you could keep that. But if you want a different base map for a different figure, you can do that too. And you'll go up to Project and Layout Manager. If you haven't made one of these before in QGIS, you won't have these options, but you can create a new layout and you can name it something unique. You hit OK, and then you're brought into the layout, the map layout screen. And so on the left side, you have a bunch of little shortcut tools for kind of the same things that are going to be up here, but I'll just be showing you from that item is where you're going to use it for the most part. And so the first thing you want to do is add your map, and you can click and drag the extent of where you want your map to be shown. And so it's not exactly like filling the full extent of this. And the nice thing about QGIS as opposed to ARC is when you're making a map in ARC and it's not on the full extent, you have to toggle back and forth and kind of like futz around with it a lot. But with QGIS, you can do everything in the map layout. So you can move the extent of where the map is viewed within the boundary. So if you click it, you can go to the left side and there's a button called Move Item Content. And so with that, you can move and change how close you could zoom in, zoom out to try and get it to fit the boundary of the box. And you just want to make sure kind of like most of the mapping polygon is in it. When you're satisfied with where you moved it to, you can go back and click away from it. And then the next thing you want to do is add a scale bar and a north arrow. So you can go back to add item. You can add your north arrow, and the same thing, you'll kind of click out the extent of it. You can make it bigger or smaller. On the right side in this panel, there'll be item properties. So every time you add something, there can be certain options you choose to change. So you can do like the fill color, how big the stroke is. You can kind of play around with it. And the same thing for the scale bar. And so it'll automatically default to like a 2-segment scale bar with meters, but you can always change that too in the item properties. So you can change it to kilometers. You can change how many segments there are, the color of them, what kind of font size you want. Oh, sweet. And then, so then you want to add your legend. And so when you first add your legend, it's going to list every single feature that you ever have located on like your main map. And so we don't want to list every single feature because we haven't used all of them. So in order to change that, you'll go over to item properties. And you can scroll down here to where it says auto update. You'll click that off, and that allows all of these buttons to be toggled on. And so you can click certain layers and then hit minus and it'll remove it from the legend. It'll still remain on your main map, but just won't be displayed for the legend. And you won't need to have like your base map shown or the Google imagery shown, so you can get rid of those. And then with the GIR too, since we didn't use every single GIR feature on this, we click some of them off. And so this is the strike slip system, so you won't need any of the normal or reverse features. So I could click one and then hit Control on my keyboard and then just click all of them at once to remove them. And some of these things I didn't use. I'm gonna kind of like do it quick and just have a couple shown for you guys to save some time so it won't be necessarily accurate. Is there a way to rotate page orientation? That I'm not too sure about. It could be in layout properties or add pages, so you can always like or the page setup. Because I've always, yeah, so you could change like the size. There's a couple different options. I always just keep it here. You could do portrait or landscape. I always keep it here, and when you export it too, you can have a transparent background so it won't show all the white space too. And then like I didn't map any secondary features in this, so I can get rid of those. And so let's say like this is fine. These are all the features I want to have. I might want to have the mapping polygon listed at the top so it's not hidden within the GIR. You can move the order of the features by going up or down. And then the next thing you'll want to do too is change the name of the features, because I don't want it to still GIR feature with the date with all the underscores. It doesn't look that clean. So you can double click on any of the features and change the name of them. So I'll just remove the date and the underscore. And then you also want to add a legend, title. And then other things you can do, like in fonts and text formatting, I like to have the title underlined. You could have the subgroups for the GIR and the fault confidence ranking bolded, just so they stick out a bit more from the rest of the feature names. You could add a frame to it, but you could kind of mess around with it a little bit and see what you think looks best. And then once we're done with that, you can add a title and a caption. And so the title should always include the location of the map and what it actually is too. So this is like a fault map, and you'll have your name and the date. You could change the font size on it so it fits the screen a bit more over here. And then you can add a caption too that just says like, this is a fault map created for like this is a pre-rupture fault map created for the earthquake, blah, blah, blah. And you could just give like a short little blurb about it. And something else too, if you start to make more than one figure on the map and you don't want to have to add a new legend every single time and then go through and delete all of the GIR features and all the other like features that you might have on the main page, you can always keep this layout the same and just this could be like your map layout, and you can lock the map in place, but you could also hide it, and you could do the same for that scale bar. And then if you save this and then want to go back to the main one and change either like the orientation and you want to zoom it in more or add different symbology to it, once you reopen the QGIS and add a map, it'll add a new one to where the updated like symbology and zoom is. So I think that was it, unless you guys have any other questions. You can take some time and like kind of playing around with it. There's other things you can do that are nice, but you just kind of base things on have like the legend, scale bar, north arrow, title, caption, and just make it look a bit clean. You can play with it how you like, but that's just kind of what we expect, at least for all of like the map exports for the reports.
Yes, so thank you, Rachel. And yeah, what Rachel just showed is we'll get you full credit, at least on the design of the map. And so I would suggest doing what she showed you, but don't spend too much time doing other things. For example, rotating the page orientation, unless you really, really want to. But we want you to get those basic things, the legend, north arrow, scale bar, title, and so forth, and then export that and put that as the PDF or PNG, whatever you save it as, into the Word document that you send to us.
When you did the click off the map situation to save the legend, were you just in the general like mapping thing? You didn't have like a specific item clicked on? Does that make sense?
Like if once I'm done editing the legend.
Yeah.
Yeah, you
Like
can just, I always make sure I like have just like select or move item and I just click away and then
Okay,
it
yeah.
locks it in place.
Sweet, thank you.
Mm. Oh yeah, and sorry, I didn't show like exporting. If you're done, you could just hit save and then layout, and you can export it as an image, as a PDF, or whatever you choose.
Any
So
questions? Okay, so next 2 weeks, we're not really going to have class, but you do have to come in, check in when it's not your spring break. This can just be really short. And then you are expected, you'll either spend the class time mapping or make up that time otherwise. And then we do want to meet with everyone in the class should meet with their respective instructors at least once. And so Rachel and I will meet with all of the ASU students and Oxford students if they would like. Rich will meet with UNR, so you should contact him, and he knows this, to set up a meeting. And I believe the McGill students will meet with Veronica. But again, so we'll have these official sort of meetings to get ideally 2 people in each meeting. And the idea is that we'll spend a half an hour talking about each person's map. You get the feedback directly on your map, but then we hope that you also benefit from discussing the other person's map as well. And then during the class time, it's also a time if you want extra feedback from the instructors to come and discuss your map. So essentially like open office hours. And so Rachel and I would like the ASU students to sign right now with us for time that works well for them. But I'd like to meet people in person. And so I will be on campus next week at this time, or earlier on Thursday. Anyone who would like to come in then. So I don't know how the best way is to set a group. Actually, maybe first you could ask if there's general questions, and then the ASU students will work on signing up for a time.
Question. So just to clarify, these times that we're setting up are outside of class time?
Yes. So class
Okay.
time, you can still get feedback from whatever instructor is there. We probably won't all be there for every class. But then you must sign up for 1 additional time.
Is that per week or what? Like, I'm confused.
Once for the 2 weeks.
Once for the 2 weeks that spring break happens.
Yes.
Okay.
And so if you don't have to meet, so you would meet with Rich, and you can work with Rich to set the time. Yes, you can meet in person with Rich. It's up to you guys to get in touch with him, and he knows to, we've all discussed this to set a time. So this is sort of, you can see this a little bit as mandatory office hours. And there'll be no other office hour during these 2 weeks. Ob, do you have a question?
Yeah, so I'm just trying to understand where we should put our focus right now. So right now we have to work on the repeatability assignment, right?
Yes.
And we have these 5 places which are making up a total of 6 maps because there are 2 for Ridgecrest, right?
There's 5 of them, 2 for Ridgecrest and 3 others.
Okay, all right, so 5 of them. And then right now we have all the data we need to work on these maps, right? Nothing to retrieve. Okay, great.
So if
And
if you're doing repeatability, you have all the data you need.
Okay.
If you have questions, actually email both me and Rachel, because we both have put the data sets together, and so you'll get your response faster.
Okay, great. But we all have to do the repeatability assignment, right?
So about half the class is doing it now. The other half will do it in April. And in April, you will do a different assignment.
Okay, that's my confusion. Okay, great. And last question. So, well, for that assignment, we are expected to do the GIR, the confidence ranking for the fault, and also like the QOA and QYA mapping, or that is not mandatory?
So you have to do morphologic or geomorphic mapping for at least one area.
Okay.
And then it is up to you, but it's probably useful to do it at least for a little bit of each area to get your head in the correct mind frame to really see what's in the landscape. But it is a little bit, it's up to you for the detail that you do it in.
Okay. And then I was reading about the report and I was not really sure exactly what we had to give back. So we need to send back the shapefiles, I guess. But then do we have to write an explanation or something? It was just like 2 paragraphs or something like that was asked for.
So you need, it's a few pages. Everyone will write a brief paragraph on the data sets they used. Then it gets more important for what you've done. So then we want 1 paragraph on the criteria that you used for the fault rankings. And then the rest of the report is about 3 pages, and each page is a figure of something interesting in one of the areas. And you should use what we just learned from Rachel to make the map look professional. And then about a paragraph of text describing what's important or how you did the mapping in that area.
Okay, great. Thanks.
Aaron, I'd prefer if we just actually set up the times now, if that's okay.
And for Trevor's question, I like having a different QGIS project for every location because the CRS for each data set can vary. And sometimes QGIS doesn't really know how to project different CRSs within the same project, and it can be kind of a headache. So it just might be, it's going to be easier on your end to just have a different project for each location.
Give another question, Oba.
No.
I have a question. Is there a specific order we should do the repeatability mapping ones in?
Up to you.
Okay.
It's sort of hoping people are gonna do it in a different order, but it's up to you.
For the NAPA mapping, the instructions are kind of vague in your email, Chelsea. Can you explain what to do first? Because I'm like, get the data, yeah. And then it says add a geologic/geomorphic map to the pre-rupture mapping. Is that both or either or?
We'd like you to spend about half the time mapping in the area in that polygon without the geologic map. So you're going to go on to Open Topography, make a digital surface model and digital terrain model, and then use pre-earthquake imagery to do the best map that you can, best fault map you can without the geologic map. And then when you're done with that, you're going to send that fault map to me and Rachel, and then we will give you the geologic map. And then you're going to refine that first map you did with the insight from the geologic map.
Okay, so I'm just doing GIR and fault mapping.
And
that's it.
Yeah, and you do need to start a little bit with morpho map or
Okay.
geomorphic map.
So
we put them both there. You don't have to do a full morphologic map or a full geomorphic, but I found that in the listening session, some students preferred one or the other. Some people did a hybrid of both and didn't do the full extent of either. They just did to the extent they found most helpful. So it's up to you. If you just want to do geomorphic, you can, and you don't find morphologic helpful if you want to do a little bit of both, but it's up to you.
okay,
It's
so I
also-
send you.
It's location specific
Okay.
also.
Yeah, so okay, I'm just repeating this back to you so I don't do it incorrectly.
Yes,
So
and
add,
Ramon is emphasizing that morpho and superficial geologic map is important for helping you to be consistent in your fault mapping coverage. And so that's
yeah,
one of the ways that you tell us that you looked everywhere, and that you can aim for these important features of your map. For example, this consistent coverage. And then we know where you don't draw a fault, that there really is no fault there.
cool. Yeah, so I just send you shape files and that's it at first. And then you send me a geologic map. And then what do I do?
Then you keep the map from before, but you want to improve it based on the new information you have from the geologic map.
So I just improve.
Yeah, you're essentially
I-
becoming a little bit of a local expert
Okay,
on as much of a local expert that you can be in a couple of weeks.
Yeah.
So we want to give you site-specific knowledge
Yeah.
from geologic investigations of that area. And the map that we're giving you is was done pre-earthquake. And so it was made with no information of that 2014 earthquake.
yep. And so I just improve on the GIR and fault mapping, do the report and be done, basically.
For March. Then
For
April.
March, yeah. Yeah, I just wanted, like, the instructions are super vague and I just was not clear on anything. So thank you.
Yes. Isabella?
Hi, yeah, so I guess for the repeatability assignment, are we doing it kind of just like how we did the normal faulting one, like Rachel said, how we kind of pick like which one works for us, the geomorphic or the geologic mapping, and we're not like creating a final project like or final product, how we map the whole area with the alluvial fans and the strike slip assignment?
Yes. So it's okay. The idea is to do it in a way that helps you. And you are getting graded on that first 2 hours of it because we do want to make sure that you do it.
Mhm.
But again, if it's faster, for example, to print it and do it on
Okay.
do it on pen and paper.
Yeah, that's what I was wondering. Like, can we sketch it? And is
Yeah, so you
like,
can
do
sketch
we
it.
want a digitized version like in the final product that we're making our map of?
No,
And
you
so
can, if it's faster, I would prefer that you do it by hand. And say you do it for every of the area. If you're doing repeatability, then you can also just take a picture, scan each one, put it in
Okay.
the report, and then make sure that one of them has that like it is a high quality map. So even if you do it by hand, add in a legend, add a north arrow, scale bar, and so forth.
Mhm.
And the others can just more add on to the end. But if you do it, we would like to see it.
Okay, thank you.
Are there other questions? So, we actually stop the